All right, we're going to determine the equation of the tangent line to this function g at 13.2, and then we're going to report it using slope-intercept form. And we're going to find this using limits. So we're going to start off with our equation for slope. So we're going to say, okay, slope is equal to, and it's going to be the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, so now let's think about what we're looking at here. So it's at this point, and here, you know what? Let's make a little sketch. So our function here, this x squared minus 9, this would be something like this, right? It's going to be some graph moving off to the side there. And they're saying when x is 13, y is 2. So when x is 13, y is 2. So there'd be a point like right there, right? So we're wondering what the equation of the line like right there is, right? That's what we're after. If this was 13 and 2. All right, so in this case, our a value is going to be really just our x value. So that's 13. And then our f of a, well, that's going to be 2. So let's fill this in. So we've got our slope is going to be the limit as h approaches 0 of, and then really this would be f of 13, right? That's my a value, 13 plus h minus, and then really it's f of 13. But on the next line down, I know that's going to be 2. So over h, which is equal to the limit as h approaches 0 of. So now at this point, this is maybe one of the trickier ones of this, is I want to write f of 13 plus h. And remember what f was. Well, it was actually g up here, but we'll pretend that was f of. So then what I like to do is I'm going to say, okay, it's going to be the square root of, and then I'm going to be replacing the x with 13 plus h. So I put that in brackets. So like 13 plus h, right? That's like instead of that x, that's what we're plugging in. And then minus 9. Okay, and then from there, it's going to be minus, now f of 13, well, that's really like our y value, right? So that's 2. If you didn't have that, by the way, if they just said it was at when x was 13, we could have found that, right? We could have found that by plugging in 2 in for x, right? So if you threw 2 in there, or sorry, threw 13 in for x, then we would have ended up getting 2, right? Because this would be 13 minus 9. It's 4. Square root of that is 2. So, okay. Over h. I'm just going to simplify up the, like under the square root here. So that's equal to the limit as h approaches 0 of, and now 13 minus 9. So this is 4 plus h minus 2 all over h. All right, so now think about what we're doing. We need to cancel this h in the denominator, right? So this is where we're going to just use some of our math skills to do this. There's not a lot of options, but one you'll start to recognize is that when you have like a square root and then like, minus some other thing, that could be a square root over here or just a constant term like it is, then what we can do is we can multiply the numerator and denominator by the conjugate of this. So what I mean by that is this would be the square root of 4 plus h. Maybe I'll make that a little smaller. And then instead of minus 2, it's going to be plus 2. And then same thing in the denominator. 4 plus h plus 2. Okay. And then it was really like this was in brackets as well. Okay, so now what we're going to do is we're just going to expand out the numerator. And the reason why we did that is because what happens is it'll get rid of my square root in the numerator there. So we've still got the limit as h approaches 0 of. Now if you've expanded all this, you're going to have that one times that, that times that, and then you've got your middle terms, or those multiplied, and then the back ones. The whole point of a conjugate pair is that the middle terms actually cancel each other out. Here, I'll show you. It actually does. It's a little bit of writing, but it'll be worth seeing. So this first one is going to be 4 plus h, right? Because you've got 4 plus h, the square root, times itself. It's just going to be the number underneath. So you've got 4 plus h. Okay, and then moving on to the next one, you've got plus 2 square root 4 plus h. And then here's where it happens, right? Now we've got negative 2 times that, so now we've got negative 2 square root 4 plus h. And then negative 2 times positive 2 is going to be negative 4. Now see what happens here. You've got 2 square root of this minus 2 square root of this. Those cancel each other out. So then the square root's gone, right? That's what I wanted to have happen. And here, let's keep going. Then that's over. And I'm going to leave this one just factored, actually. So it's h, and then just times square root of 4 plus h plus 2. And I'm leaving this factored because I actually want to cancel that h. That's the goal, right? So if I expanded that back in, it'd be a little harder to see. Okay, so now, if I look up to the numerator, I can probably do it at this point too. I've got negative 4 over here and positive 4 over here. Those are going to cancel too. So those cancel. So you can see everything, you'll kind of know you're on the right track when everything starts to cancel out in the numerator. But now we've got the limit as h approaches 0 of, and all I have up top now is just that h. So it's just going to be h over h, and then square root of 4 plus h plus 2. And now I can cancel my h. And now we're ready to actually take the limit. So let's write this one more time. Approaches 0 of, and now this is just 1 over the square root of 4 plus h plus 2. So we are good to throw our 0 in. So this is actually equal to 1 over square root of 4 plus 0. Right, throwing that in for h, plus 2. So this is really saying the square root of 4, that's 2. And then 2 plus 2 is 4. So this is all the same thing as just 1 over 4. So what is that? Remember, that's my slope. So what I just found is that the slope of this line is 1 over 4. So the slope is 1 over 4. Okay. Now from there, we're getting there. We're almost done. I also know on this graph that there's a point. There's a point that's 13, too, right? There's a point on this line. So if I have a slope and I have a point, a good equation to throw it into would be slope point form, which is y minus y1 is equal to m x minus x1. And that will just throw it all into the equation. So my y value is 2, so y minus 2 is equal to 1 over 4, and then x, my x minus 13. And now I just need to rearrange this and solve for y, right? So I got to get rid of the brackets. So one thing I like to do, you could expand the 1 over 4 into this, but I like to just get rid of that denominator right away. So what I'm going to do is I'm going to multiply this by 4. But whatever you do to one side of the equation, I have to do that over here as well. So I have to multiply like this term by 4 and this term by 4 as well. So this becomes 4y, and then 4 times 2, so 8, is equal to, and then the 4 is canceled. That was the whole point there. So now I just have x minus 13. I want y on its own, so I'll bring the 8 over. So 4y is equal to x minus 5. And then just now divide everything by 4. Divide by 4, divide by 4, divide by 4. So our final answer is y is equal to, and I could write it as x over 4, but I'm going to write it as 1 over 4x, just so I can like clearly see my slope, minus 5 over 4.